At the start of this course, we described data modeling as the process of analyzing a target business domain in terms of its entities, and then the relationships among those entities, and then the cardinality of those relationships. So let's take a look at modeling entities in JSON. So first, what is an entity? It could be described as an object that's modeled in a database management system so that the states and relationships of individual instances of that object could be persisted over time. So if you have an order processing system, you might have entities like customer, order, item, product, address, and pay type. So the question becomes, how can you describe those in JSON document attributes? Well, what are the entities in this very simple use case? Imagine you have a customer who creates an order. That order has a pay type. The order also has one or more items associated with it, and each one of those items, each row in the order, has a product assigned to it. Now, each of these has various attributes associated with it, like a product has a name, description, and a price, and each row in the order, each one of the items, has a quantity associated with it. Customer and pay type each have names. So who are the actors in this particular system? Are each one of these, customer, order, items, product, and pay type, an actor? Perhaps are order and items so closely related that they're a single entity? Or maybe each item and its product and the quantity is its own entity, and the order and pay type are a single entity, customer remaining a single entity of its own. This is ultimately as much art as science, and it depends largely on the programming environment that you're working with. So in JSON, you have to think about what is the structural boundary of an entity and why. Is it each document, each attribute, certain attribute types, certain combinations of attributes? Could an entity be described by multiple related documents? Well, JSON is flexible, and all these remain open questions because ultimately you could do it in any of these ways. The data modeling is agile, and it's going to evolve with your discovered usage patterns. However, as a general rule, normally in document databases, each document would best correspond one-to-one with your domain objects if you have a choice to model in this way. Doing this reduces or completely removes what's known as the impedance mismatch between your code and your persistence. It lowers the barrier in getting your data into object form inside your code. But this relationship is not enforced or required. It's simply a good practice. So what factors influence your structural choices? First, you have to think about the size of your document ID and the document itself. The document can be up to 20 meg, but how large do you want it to be? What will the transfer time be of your documents? How long to serialize them in memory? How long to replicate them in memory? Also, regarding your document IDs, as we've said, you need to think about the caching impact because by default, document IDs are stored in metadata. What's the target environment? Are these documents going to be loaded into a mobile device, or is this all happening on some very large server? Next, you want to consider atomicity. Couchbase 4.5 is capable of updating an entire document at once or specific attributes within a document. But this does mean that if you need to update multiple attributes in sync with one another, you'll need to place them in the same document. What about update complexity? You can duplicate data across documents, and we'll talk about strategies around this. But if you do duplicate data for various reasons, including speed of access, when is that data updated? Does it need to be updated? If so, how often, and how are you going to track this? Again, we'll recommend some strategies around this in the next lesson. What about the strength of your entity relations? Related data can be co-located or duplicated in a single document. Do you need to access related data with minimal network traffic? Perhaps that's a reason due to tight relationships between, for example, an order and its items to locate all that data in one document rather than divide it up. Last, what about the complexity of code mapping? JSON does easily map to code, but would a particular document make sense as a code object? How complex would that object need to be? Are you working with a pre-existing code base, or do you have the opportunity to design your object model and your data model in sync with one another? So in this course, we're working with a conceptual model for an application we call Couchgadget, a very simple ordering system to buy gadgets, and it involves a customer that creates an order. Well, the customer has contacts and has addresses and has pay types, but the order itself may have multiple addresses for shipping. It also has a pay type, one of the available customer pay types for that particular order, but that order also has one or more items, and each item has a product, but it also needs to have locally within the order the quantity and discount related to a particular item being ordered. So where are the entities in this diagram? Here we'll suggest possible entities by color, but these are just guidelines, and in the physical implementations we show ahead, you'll see different choices being made. So, is an entire order a single entity in a single document? Or is there more than one entity involved here in this document? Perhaps the customer is an entity. Or maybe there's a customer and an address as separate entities and you shouldn't munge the data together. Perhaps each item like email and Twitter is its own contact. Is each contact an entity of its own? And should each entity have its own document? Here we see that the contacts could be listed as an array, where each element in the array is a document ID, and then all of the detail for that particular contact is contained in a separate document. Well, is document size an issue? Is this a mobile app or a server app? Does this data need to update atomically? It has to be in the same document for an atomic update, but perhaps that doesn't matter with contact information. Is speed a factor? Should all of this data be contained in a single document so that it's immediately available without any further joins or requests? Or maybe it's not actually duplicate data, but a snapshot of an internal document that you would then timestamp because you're recording the state of the data at a particular point in time. How easily are each of these documents going to map into your code base? Again, is it new or existing code? How would you answer these questions differently if we were talking about pay types or addresses? What about products in an items array in a given order? Why would you answer these questions differently? That's what we want you to think about here. So what have you learned in this particular lesson? Well, first, an entity is an object that's being physically modeled in a database management system so that you can persist its states and relationships. Commonly in document databases, there's a one-to-one correspondence of your entities and the underlying documents. However, this is not required and it may not be possible in your system, but it's a good idea to keep in mind where possible. There are a lot of factors that inform the choices you're going to make around document structure. What is the size of the document and what is the size of the document ID? What will the impact of these sizes be on transfer speed, serialization in your client, and overall power use if you're working in a mobile environment versus a server environment? Do you need to consider atomicity? Remember that although in Couchbase 4.5 you can perform updates on a whole document or on an individual attribute, if you have multiple related attributes that must update atomically, then you're going to want to place them in the same document and update them at the same time. What about the strength of entity relationships? How does the structure of your documents relate to the structure of your object model in code? And what is the complexity? If you have an extremely complex document structure, how hard is it going to be to map that into your code? All of these are good factors to keep in mind as you design your documents. In the next lesson, we're going to start looking at physical implementations of this conceptual model and then hand you off to a lab where you get to walk through these documents yourself, examine them, and in the lab after that, we'll have you start designing your own documents for a new conceptual model. Stick around.